We are going to step into something which is called kinematics. So kinematics means something pertaining to motion of the particle or system. Now we already know that the average velocity is given as change in displacement let's get the other half of t divided by change in time, right? And if we assume that we are traveling just in one direction, let's call this kinematics in one dimension, because that makes a difference. Things are much easier in one dimension. Alright, so if we are just moving in one dimension, which means just along the x-axis, then let's say if we start traveling at position xi and end our journey at xf, and let's say the initial time was ti and the final time was tf, then the average velocity is given as fxf minus xi, which is change in displacement. Well, this is a one-dimensional motion, so you can clearly see that this should be xf minus xi divided by tf minus ti. This is average velocity. I would like to introduce you to something called instantaneous velocity. Now let's say it was you who was traveling from xi to xf, and you were traveling in your car. Well, you can certainly calculate the average velocity by using this formula, but while traveling on the highway, you might have noticed that actually your speedometer is not really at one particular place. It keeps on changing positions. What is this velocity that this speedometer is telling? Well, this velocity is called the instantaneous velocity, which means what is the velocity at that particular instant, which means that what the way it's understood is this. So you travel xi, you are at some position xi, and then you travel a very small amount xi plus delta x, and you did that in ti, from ti to ti plus delta t, and these delta x and delta t are very small, which means they pertain to an instant. Then your average velocity will be you can clearly see it should be delta x over delta t. Well, in this particular case, your average velocity will actually be called instantaneous velocity, because this was only for an instant, and only for instant these things are small. So when these two are smaller quantities, that means we do not take into account a longer period of times, then we are actually calculating an average velocity, which is called instantaneous velocity. I hope it made sense. So let's talk about kinematics. Now, what does kinematics deal with? Kinematics deals with relation between displacement, velocity, and acceleration, right? And this is an important topic. Why? Because we deal with displacement, velocity, and acceleration daily in our lives. While traveling, we always deal with these three guys. We displace ourselves, we move with certain velocities, and we sometimes speed up and speed down. So that is the reason why we are discussing about kinematics. and we may be moving in very ever-changing ways. It's not that you start traveling with a speed of with a velocity of 30 miles per hour and you just keep traveling with that speed. No, we accelerate, we reach certain speed, we brake and then accelerate, and we travel different distances. So it is important to understand the relation between these different variables, and the three equations that are required to understand different relations between these variables are: the first case, if you start your motion at xi, you travel with velocity v for time delta t, or let's not talk about that, let's say delta t, let's say it's tf here, no, tf here, and you end xf, oh I'm sorry, this is ti here, and xf tf. So what you do here is this: we start at position xi at time ti, we travel with velocity which is constant, and then we end at xf at time tf. How are these variables related? We already have seen this. These are related as xf equals xi plus v tf minus ti. So that is the first scenario, the case when you are traveling at a constant speed. Second, let's say you start in your car at position xi at time ti, also you have a velocity vi initially, and you travel with an acceleration a, which means you're going on a highway and you wanted to accelerate or increase your car's speed, and you are at position xi and you're moving at position vi, and the time was ti. You accelerated such that you reached velocity vf, position xf, and time was tf. Now these variables can be related using these two other equations, which are vf equals vi plus a tf minus ti. Also you can write vf square equals vi square plus 2a xf minus xi. And there's one more equation, which is xf equals xi vi t f minus ti plus half a tf minus ti squared. Right? Let's see some of them. Well, you should have identified this one clearly. This equation is nothing but a rearranged form of this particular equation. The second one is nothing but definition of acceleration. We know that acceleration is change in velocity divided by change in time. This one, you see, this first half is same as the previous equation, but in the previous equation there was no acceleration. The guy was traveling at constant velocity. But let's say that he's not traveling at constant velocity but at a constant acceleration when he traveled at a velocity, when he started his journey at velocity vi, which means that you have this term, but this added term comes because of the acceleration. So you see, you can compare these two equations. This is the case when you clearly see if you put a equals 0, which means there is no acceleration, your equation reduces just to this, right, which is same as the first one. So this is because of just definition of velocity, this is because of just definition of acceleration, this is again definition of velocity, plus also you have an effect because of acceleration. But this one is new, and we really don't want to really understand how this is coming. We can, but it's not really a issue right now. And this relates the initial velocity vi with the final velocity vf, and given there is some acceleration a, right? So in a way, actually the only important ones are this one, and this one, because you can certainly reduce the third one to this particular one. So these are the three basic equations which are going to be important in kinematics, and all they are doing is relating different variables, and the different variables are the initial velocity, initial speed, the initial position and the final position, the initial time and the final time, the initial velocity and the final velocity, right, and the acceleration. And these three sort of relate all of them. In the next lecture we'll take some examples on how to use these equations. Alright, bye bye.